Welcome, everyone. We are so excited to be sharing our release of EMQX 5.1. In this webinar, my colleagues will be delving into the benefits and features of the most advanced MQTT platform update, featuring an inside view of why it's crucial to not only scale, but leverage new advancements and why they're important for your business. That includes MQTT over QUIC, large file transfer capability, IoT data channel unification, and complete visualization of all bidirectional integrations. I'd like to begin by introducing our presenters. Today, we are joined by two of my coworkers, Carrie Ware and Ernest Russell. Carrie is a sales engineer here at MQ, based in Europe. Carrie has worked in a variety of technical and sales engineering roles since 1988. An interesting fact about Carrie is that from 2006 to 2019, he worked at IBM Internet of Things, where he helped create a modular training course framework for IoT. So he's definitely well-versed in this field. Ernest Russell is our technical content manager here at EMQ, working in our marketing department. He brings over a decade of experience in information technology and broadcast engineering, supporting some of the largest media companies in the world, including CNN, Turner, and Fox. Ernest has always been passionate about learning and writing, earning a master's degree in networking and telecom management. As a technical content manager, Ernest is focused on knowledge sharing and best practices for MQTT and IoT. So just want to go over a few housekeeping notes before we begin. Please note that this webinar is being recorded. The webinar will last approximately 30 minutes, with the remaining 15 minutes allotted for Q&A. Feel free to submit your questions with the Q&A tab, and we will address them at the end of the presentation. So without further ado, Ernest, the stage is yours.
Thank you, Rosemary. What a beautiful introduction. And so we'll get started right away here. I am going to go over an introduction to MQTT and QUIC, and I'll also go over some new version highlights before I hand off to Carrie, and he will cover our cluster architecture, our MQTT large file transfer feature, and jump into a live demo of our dashboard so you can get a look at some of the improvements that we've made. And I'll say that it's not just a dashboard improvement or a reskin. We have some really groundbreaking features that we're excited to talk to you about. So let's get started. So with MQTT, it is a client-server publish-subscribe model. And so a publisher or a subscriber subscribe to a topic. And the good thing about it is it requires a very small code footprint, and it also works great and very reliable in situations where network bandwidth is not so great. And QUIC, QUIC. So you'll hear that term from Carrie a little bit later. And so I want you to understand exactly what he's talking about. And that is, QUIC is a network layer protocol. It's built on top of UDP and originally proposed by Google as an alternative to TCP over TLS. And it's really because of some of the features that it has over remote and wireless networks, it's becoming the underlying next generation protocol. So MQTT over QUIC, EMQ is the first to implement this technology where it uses UDP instead of traditional TCP/IP. And there's several advantages there, including some reduction in the overhead for handshake, and also some improvements in those situations where, again, network bandwidth isn't so good. Our developer advocate did a test where we had a TCP/IP client and a client connected via QUIC, and the IP address was changed, changing that network connection. And the QUIC client was able to recover just about immediately with no disturbance, while the TCP/IP client lost connection. So we're definitely seeing some advantages there to using MQTT over QUIC, which is available in the new version. So speaking of the new version, let me give you some highlights before we hand off to Carrie. And so some of those highlights are our new core and replicant cluster architecture. And Carrie will go into more detail about that. More about MQTT over QUIC, large file transfer over MQTT, which has been a struggle in the past. Rolling upgrades without downtime are now available because of this new architecture. And we've redesigned our data integrations and our dashboard, allowing you to visualize your rules using flows, and also have some new features in our rule engine with JQ. So with that, I will hand off to Carrie, and we can get into the meat of this.
Great. Thanks, Ernest. Yeah. So first of all, hello, everyone. And what I wanted to talk about first is the new architecture we have for our EMQX broker cluster. I'll talk about what has changed from version 4, why we changed it, but more importantly, I want to talk about how you can use this new architecture to collect data from hundreds of millions of connected devices. So I'll explain everything with an example. So suppose we have a broker cluster with 1 million clients connected to it. And let's look at just a couple of those clients. We have a publisher that's publishing data to a topic called sensor 1 temperature, and we have a subscriber that's subscribing to the same topic. So let's delve deeper into the cluster and see how those messages are transferred. So next slide, please. So here we can see that we have a 3-node cluster. So that's 3 instances of EMQX running in their own nodes. So you can see that the publishing client is connected to node 1, and the subscribing client is connected to node 2. So that means in order for this to work, node 1 needs to know to forward the message to node 2 so that node 2 can deliver it to the subscriber. So in EMQX, the method that we use is we have a topic routing table. And so basically the topic routing table maps the topics to nodes that have subscribers. So in this case, sensor 1 temperature is mapped to node 2. So all nodes need to have their own copy of this table. And not only that, but the table needs to be updated every time a client subscribes or unsubscribes to a topic. So you can see that this table is quite dynamic, and also those updates have to be delivered to every node. So next slide. So in prior versions, for example, EMQX v4, all the nodes were connected in a full mesh topology. So the problem is where every node is connected to every other node. So the problem, as we will see, is that's not very scalable as the number of nodes increase. So for example, if we have 3 nodes, we have 3 communication links between the nodes, and that's kind of okay. But if we expand the nodes, if we have 10 nodes, then the number of communication links, as you can see on the circle on the right, gets quite large. So it's actually 45 links. And it's difficult to count the links, but if you add up all of the arrows and divide by 2, you'll see 45. You'll get 45 connections. And if we have 20 nodes, then the number of those links increases to 190. So the problem with all this is this becomes a bottleneck to scalability. So next slide. So this is what we changed in version 5. We defined 2 different types of nodes, a core node and a replicant node. So the core nodes behave exactly the same way as the v4 nodes. In other words, they are connected in a full mesh connection, and they're sort of the master nodes. They have read-write access to this routing table. Then we defined a replicant node, and the replicant node connects to only one core node, and it connects in sort of a client-server type manner. but it only has read access to the routing table. But you can automatically, you can see that this architecture is much simpler. So if we look at the numbers, if we have 3 nodes, it's still the same. We still have 3 links, communication links between the nodes. But if we look at 10 nodes, then we've gone down to only needing 10 links of communication between all of the nodes. And if we go to 20 nodes, we have decreased it down to 20. So we've gone from needing 190 communication links down to 20. And these communication links represent sort of performance overhead that needs to happen. So we have basically reduced it down to where just adding a single node only adds a single link. So that is what enables us to achieve the hundreds of millions of connections. And one note that I want to point out is this architecture is only used for updating this routing table and performing some housekeeping. It's not involved in delivering messages. So that's an important concept. So when a message arrives at a node, it can deliver directly to any other node. That message does not have to pass through the Chord nodes. It's only this mechanism that's used to update the routing table. So so that's basically what we've done. Next slide. The other feature we have now is large file transfer over MQTT. So basically what a client will do if it wants to transfer a file, it will break the file down into segments or chunks. It will send each segment as a normal MQTT publish message to the broker. And then the broker will reassemble that file and store it either, currently the file can be stored on the broker itself or in an AWS S3 bucket. So that's configurable. So the way to retrieve the file is through the API with a link. So next slide. So if you want to try this out yourself, we have a Python script that allows basically transfers large files. The only thing you need to do is just pass it through a couple of parameters. One is file ID and of course the file that you want to transfer. And it uses a new $file topic mechanism with the file ID to first publish an init, that's sort of metadata for the file. Then it publishes each of the segments in order. And then finally it publishes a finish topic that basically lets the broker know that it can now reassemble the files. And here's an example of the link that would be that a client could retrieve the file using that link. So that's very powerful. Next slide. So also we have support. We have added support in our rule engine for JQ. JQ is sort of a filtering mechanism, filtering language. And our rule engine, what it does is it allows you to process messages in real time as they come on to a topic. So we've expanded our rule engine to include JQ. So here's an example. If you look on the left, there's 3 sensors, sensor A, B, and C. And each of those sensors have data. And so what we want to do with this rule is to compute the average, but also exclude the high and the low data values. So what it does is it iterates over those 3 sensors. It takes the data, it sorts the data, it removes the first item, then the last item, and then computes the average, and basically passing through different filters. And then it outputs 3 messages containing the average value. So this is quite a powerful mechanism that expands our rule engine. So next slide. So now I'll go into a demo and show you a couple of things. So first of all, what I want to explain is what I'm going to demo. So I'll show you the new dashboard. It's quite user-friendly. We've got a lot of compliments about it. Also, I'll show you our data integrations. We have restructured the menu. Also, if you look to the right, you can see we've integrated with help. So you have access to our documents, forms, GitHub, blogs directly from the dashboard. So you have access to a lot of information. Next. We have a lot of data integrations that allow you to take the data from the topics and forward them to backend systems. And we have a lot of integrations that you can see. Also, new to EMQX5 is a visual diagram of the rule engine. So you could see where the topics it comes from, the rules themselves, and also which backend database or Kafka it's going to. Next. And the other thing I want to show you is I'm going to be using a couple of tools for testing. One is what we call EMQTT Bench for load testing. It's the same product that allowed us to test 100 million connections, so it's quite powerful. I don't quite have that many in my test demo. I have 50 connections, but I will connect 50 clients and they will subscribe to 50 different topics. And if you can see at the very end, they will be connecting over QUIC. So 50 clients will be subscribing, 50 clients will be publishing to 50 different topics. And also I'll show you MQTTX, which is our client testing tool. So it's really good for, you can put in different payloads, you can test different clients, and also you can test the MQTT spec protocol. So it's quite handy for test. So I'm going to take over. So here is EMQX version 5 with a pretty cool dashboard. You can see, for instance, the number of incoming and outgoing messages. I can see the number of connections I have. It shows live connections are the ones that are connected to the broker now. All connections are the ones, it includes persistent clients. So there could be a difference. Topics, subscriptions. You can see the node, the architecture. I only have one node, but if you had core nodes and replicate nodes, you could see which ones are core nodes, which ones are replicate nodes. It also shows a graph of the above data. You can graph it over up to the last hour, up to the last week. And if I pick 6 days, you can see the data changing. Basically, it's the graph of the same metrics that were at the beginning. One thing it includes is dropped messages. So that happens when could happen when there's no subscribers. So I purposely started the publishers before the subscribers just to get some dropped messages. So we can also see the clients. So these clients here, they are the ones from MQTT Bench. So you can see these clients. If you want to see how many clients are connecting over in QUIC, you can see that I have 100 clients connecting over QUIC and 3 clients connecting over TCP. So QUIC and TCP. I can, let's see, look at the subscriptions. So you can see that bench client 11 is connected to are subscribing to topic bench 11, so on and so forth. And for one of the main things I want to show is the data bridges, because this is quite powerful. I've got data bridges for Kafka and MySQL, but Zoom is hiding the controls. There. Okay, so this is the different data integrations that we support. For instance, Kafka, MySQL, Google PubSub, MongoDB, InfluxDB, Redis. I'm sure you can recognize some of the databases that you're using. And this is very powerful because it means that you can store data directly to these backend databases without having to write any custom software. And I'll show you, here's the flows. So you can see visually what the rules are. So I can see I have a rule that's monitoring data on sensor one topic, sensor one data. It's sending the data to Kafka. Another rule is sending the data to MySQL. So, and here's the different rules. So let's go look at those. So the rule to send the data to Kafka this is using not JQ, but this is using the SQL type syntax to choose the data that you want from the payload from a particular topic, and then forward that data to Kafka. And keep in mind that if you have millions of messages per second, then this rule is gonna run 1,000,000 times per second. So it's quite powerful. So that was the rule for Kafka. The rule for MySQL and the rule basically for any data integration that you have all looks the same. You choose the data that you want, and then you just forward it to the back end. So it's quite a powerful feature. Also, you can reach into the payload and monitor for alarms. So for instance, if you want to monitor if a temperature is over a certain amount, you can do that, and then you can set an alarm. And when I mean set an alarm, I mean republish to a different topic. So this is going to publish to the alarm topic. And the last one I want to show is one that monitors internal events. So the broker has internal events for when a client is connected, disconnected. You can monitor all of those. So we can tell the connection status of any client. And that's quite powerful. And then just to quickly demonstrate those rules, let me go to, this is MQTTX. So I've got 3 different clients. I've got one client that's acting as the sensor with its payload of data, and it's going to be sending its data to a topic called sensor one data. I have another client that's monitoring just the raw data, the raw topic data. But the other client, let me clear it, is monitoring the output of the rule engine. So if I look at this value here, notice it's above 50. So if I publish, I see that this client has received the raw data, but this client has received the alarm output. So this, because it's subscribing to the alarm, it receives the alarm notification. If I disconnect the client, I can see that it shows that the status of the client is disconnected. If I connect it back, you can see that it shows it's connected. And then if I look at Kafka, let me change this value to something we'll recognize. Let's say 25.5. And if I publish it, notice it's kind of flickering in the background. And that's because it's writing this data 25.5 directly to Kafka. And if I go to MySQL, I can see it's also written the data to MySQL. So every message that comes into that topic, it's going to process it and write it to the backend databases. So, and sort of the last thing I wanted to show was the help. So if you click here on help, you get documentation. So you click on the link and it takes you directly to our documentation. You can go to our forums. You can go to GitHub, our blogs. So basically you have a lot of information right at your fingertips. So basically that's the end of the demo. That's what I wanted to show. So I encourage everyone to try it out. I think you'll really find a lot of value from it. So
I wanted to go ahead and thank you for sharing such an insightful and informative discussion today. I do want to go ahead and use this time for some Q&A. So we had some questions that came in. So let's go ahead and kick that off. And again, if you have any questions, those that are out there, you want to go ahead and submit them. We still have time. We'll get through as many as we can. If we don't get to them, we will definitely follow up with you after the webinar. Here, the first question that's come in is there a file size limit that can be sent over MQTT? And I think, Carrie, this might be a good question for you.
yeah, there's no hard limit. It really sort of depends on the underlying hardware. So probably the limiting factor is the RAM on the underlying hardware, because the broker needs to reassemble the file. So it would probably need enough RAM to support that. So as far as our broker is concerned, there's no limit.
Okay, thank you. Next question. What is the advantage of using QUIC over traditional TCP or IP? And Ernest, I think you can take this one.
Yes, and so actually there are several advantages. One is if you have, let's say you have a situation where your network is bouncing, right? We've seen that where the network disconnects, it connects, it disconnects and connects. When you have that over a traditional TCP/IP connection, both the client usually gets very upset. It gets disturbed, and it's not able to continue to generate messages. Versus the QUIC client, it carries the data on a separate channel than the connection, and so the client doesn't care if the network connection switches, goes from, let's say it goes from Wi-Fi to a cellular connection. It can make that transition pretty gracefully. And if you are in a situation where you need to fall back to TCP/IP from QUIC, we will support that. And so if it can't establish the QUIC connection, it can definitely fall back to TCP/IP.
Great, thank you for the explanation. Another question. We use SQL for our rules engine. Can you use both SQL and JQ in the new rules engine? And Carrie, I'm thinking that might be one for you.
Yeah, and the good news is, yeah, you can mix and match. So that's not a problem.
Perfect. All right. We have another question. Does it support connection migration? So
I'll let Carrie
guys can take
tackle
the lead.
that one.
Okay.
Yeah, I believe it does.
And I believe we're talking about the client. So yeah, so if we're talking about client migration, yes.
Okay. Next question. What is the difference between MQTT 3 and the 5.0?
I can tackle that one, and because I don't want to cause confusion between our versioning, our enterprise EMQX version 5.1 and the MQTT spec. And it looks like here that's referring to the MQTT spec, which we do support versions 3 and 5. And the difference would just be the evolution and some of the groundwork that allows us to build these new features. Carrie, anything to add on that?
Yeah, I can add that our tool, MQTTX, is a good tool to sort of experiment with the differences between MQTT 3 and 5, because it has all of the parameters of MQTT 5, like there's user parameters and topic aliases. So there's a bunch of things that MQTT 5 added over and above MQTT 3. So our tool, our MQTTX, is a good tool for exploring those differences.
Perfect. Carrie, this one's for you. So it was the shown dashboard that you displayed available only on the enterprise version?
Yes and no. It's similar on the open source version, but as far as the backend databases, the version I showed was enterprise version that included the backend databases. So the other open source version is similar, but it doesn't include all the features of enterprise.
Next question. Can you comment on the difference between QUIC and MQTTSN?
Yes, I'll take that one. I'll start with that one. So MQTTSN, MQTT for sensor networks, is as I described with MQTT, it's a messaging protocol, but this SN is specifically built for sensor networks. So we're talking devices that are maybe battery operated, or maybe these devices go to sleep and wake up. So it is very efficient on reliable messaging while maintaining that battery power without being so power intensive. And versus the QUIC protocol is more of an internet transport protocol built on top of UDP instead of TCP/IP. Which gives us several advantages, including that ability to carry the network connection on a different stream.
Okay. Next question is, does the software support LDAP Azure AD authentication? And can I have a topic ACL rules for groups?
I'll let Carrie tackle that one.
Yeah, but yeah, I'm not positive on the LDAP. I think it does. For the ACL groups, generally ACL is for clients, but I think if you, depending upon how you name your clients, I think you could sort of create that behavior.
Okay. The next question that's come in is, how much does it take on average to publish the data?
When say how much I'm assuming we are talking about time, and so this is done within milliseconds. So again, is why the MQTT protocol is so efficient for IoT. Is you do have lightning fast messaging, again, without a heavy payload. Very lightweight still, but yeah, we're talking sub-second messaging.
Okay. Next question. Is there any data limit constraints on MQTTSN and MQTT 5.0?
I'll let Carrie tackle that one.
Yeah, the answer is yes. For MQTT 5, it would be the same as 3. And the data limit is 256 megabytes. MQTT-SN is less, although I'm not sure exactly what that number is.
Okay. And another question, how complex is it to fully migrate version 4.4 to 5?
Carrie's done that several times. I'll let him speak to that.
Yeah, I've done it a couple times. So it's not so complex, and we are developing sort of little helper tools to help that process. So it will be easier.
Mhm.
All right. Final call for questions. Looks like we were able to get through the ones that have come through so far. So if we have a few minutes here for any final ones.
Nice. Rosemary, I would like to thank everyone. We have some contact information here. If you would like to reach out to Carrie at sales@emqx.io. Also, if we have a pretty good attendance today. Thank you very much. we also have some contact here for partnerships. So you can reach us at partner@emqx.io to talk more about that.
Okay, well, actually, I did have another question come on in. So this question is, when they're using large amounts of data with MQTT, it takes a long time. Is 5.0, I'm trying to rephrase this one to make sure that it was asked and we're answering it properly. So, and using large data through MQTT, it takes a long time. So are there any constraints depending on size when it comes to 5.1?
It sounds like this one is speaking about the time to process messages, and I'll refer back to Carrie's comment that especially when we're talking about large files that we have the ability to send over MQTT now, it really depends on the hardware, right? If we have a lot of RAM or we have accelerated GPUs that are reassembling the data, that will definitely help speed up things. But I'm assuming that's talking about large data transfers, but messaging is still, even when we tested connecting 100 million clients, we were still able to achieve sub-second messaging.
Great. Okay. And another question. Can we monitor all the broker environments from a single point in an architecture with on-premise, different instances, and a cloud centralized one?
I'll let Carrie tackle that one.
Yeah, I'm not sure. I don't want to say. I'm not 100% sure.
Yeah,
Okay.
so it's one that maybe Halen, maybe we can follow up on you with that and get more information about your particular requirements. It sounds like a pretty complex environment.
Okay. Well, like I said, if you were shy on today's webinar to ask any questions, feel free to reach out. You might want to go ahead and take a picture of the slide that's up. Feel free to go ahead and reach out to us. Wanted to go ahead and thank our presenters today. Thank you all for joining us. And this concludes today's webinar. So we'll send you the recording of the session shortly if you'd like to have a replay. And thanks again for joining, and enjoy the rest of your week. Thanks, everyone.